Good morning, afternoon, or evening, cats and dogs. Today's video is going to focus on the lesson 6.1 guided notes on solving one-step equations by addition and subtraction. Please make sure you have these guided notes in front of you and you're copying down not only the solutions but also the work that goes with these problems. This is a really foundational concept. This is something that we'll be talking about in class as well. We'll also be spending some time during our live session on Friday doing some additional practice through quizzes. But I really want to make sure that you have a solid foundation in solving one-step equations by addition and subtraction. Because later on this unit, we're going to be doing inequalities with this, and we're also going to be doing two-step equations that involve both addition and subtraction. So it's a very important concept. Remember that you can use your guided notes as you can use your guided notes for any graded classwork. You should also use your calculators to work through these problems. So you don't have to calculate any of these things by hand or mentally. You can certainly do that and then just double check it using a calculator. So please make sure you have that handy as well to practice plugging these things into the calculator also. You will get a practice worksheet on this lesson so that you'll have a chance to practice this both in class and outside of class as well. So first things first, I do want to introduce the addition and subtraction properties of equality. The addition property of equality says that if you add the same number to each side of an equation, then the two sides remain equal. So we kind of did this when we were doing our pre-lesson 6.1 notes in terms of showing the same operation on both sides of the equation. The subtraction property of equality says that if you subtract the same number from each side of an equation, the two sides remain equal. So if we do the same thing to both sides of an equation, both sides are going to remain equal, which makes sense. It's going to keep it balanced. So let's go ahead and do some exercise problems or some example problems on solving one-step equations. You'll notice that there are some examples that are shown for you and some that we're going to work through together. So question number 1 is one that is shown for you, and it says in the directions, to solve each of the following equations, show your inverse operations. You should always show your work, always show your inverse operations. Eventually, I do hope for you to get to the point where you don't necessarily need to list what's happening to the variable, as I'm going to highlight in yellow here, and the inverse. But at this point, I'm still going to jot this down for each of these questions, at least for the first half of this unit. So number 1, our equation is x plus 12 equals negative 5. What's happening to the variable is we're adding by 12. So we're adding 12 to the variable x. Remember, there are two inverses, and we make one change to make an inverse. So your inverse is either to subtract by 12 or add by negative 12. So I actually showed both, but you would only need to represent it one way underneath. So you can either subtract 12 from both sides or add negative 12 to both sides. Now, assuming you use the inverse operation, since the inverse of adding by 12 is to subtract 12, this should cancel out and become 0. Plus 12 minus 12 becomes x plus 0. Now, I don't typically write this step. I'll automatically go to the final solution, so you'll see that in all the future examples. But you'll end up with x at the end. And that's our goal, is to isolate the variable. On the right-hand side, I'm going to highlight this in blue. This is what you would be plugging into the calculator. Either negative 5 minus 12 or negative 5 plus negative 12. So again, in your calculator, and please practice doing this, because some of my students will say, oh yeah, well, I know how to plug it in, and then come test or quiz time or something that's graded, they don't really know how to plug it into the calculator. So practice plugging this in. Negative 5 plus negative 12, with or without the parentheses, or negative 5 minus 12. And make sure that you're using the subtraction sign for subtraction or minus, you're using the negative key for any negative numbers. You should get negative 17. So x is negative 17. Now the good news is you can check your solutions. So grab your calculator again, replace x with negative 17. Do negative 17 plus 12, hit equals. If it does not equal negative 5, then your solution's incorrect. So you need to go back and look at your inverse operations again. As long as it equals what's on the opposite side of the equation, you're good to go. All right, number 2, negative 18 equals g minus 26. So the thing that's happening to the variable here is we're subtracting by 26. And I know it's kind of hard to tell the difference between subtraction and a negative, but again, we're subtracting 26. The inverse of that is to add 26. Remember, you could also do subtract a negative. So you're going to notice now I just retyped the equation again just to make my work a little easier to show, but I'm going to show plus 26 on each side. So again, on this right-hand side, because I use the inverse operation, it's going to cancel out, and we're going to be left with g on the right-hand side. But what you want to plug into your calculator is what I'm going to highlight in blue. It's going to be negative 18 plus 26. When you do that, you get 8. So your solution is g equals 8 or 8 equals g. I do often have students who ask, well, is it okay if I write 8 equals g? Do I have to flip it around? You don't need to flip it around, but 8 equals g is equivalent to g equals 8. Hi, Oliver. Yeah, yeah. All right, so for this question, again, you're going to get g equals 8. One way you can check your solutions is to do 8 equals 26, hit the equal sign, and see if it equals negative 18, and it should. Sorry about that. My 2.5-year-old, almost 3-year-old, running in trying to tell me how excited he is. All right, number 3, we've got negative 14 plus y equals 31. What's happening to the variable is we're adding by negative 14. So the inverse of that is to add a positive 14. Again, I do hope for you to get to the point where you can just work through this mentally. I don't ever have to show this when I'm solving equations, but since this is really our first foray into this, I think it's a good idea for us to show this work at least for the first half of the unit. So again, I'm going to show plus 14 on both sides. It's going to cancel out on the left where the variable is. On the right, I'm either going to do this mentally or plug it into my calculator, and I'm going to end up getting 45 for my solution. So 31 plus 14. Remember, do negative 14 plus 45, hit equals, make sure you get 31. It's a good way to just quickly double check your solution. In number 4, I really do suggest adding the opposite. So rewriting this as z plus 29 equals negative 74. So what's happening to the variable is add by 29. Now, if you have minus a negative 29, that's okay. Your inverse should still be the same, either subtract 29 or add a negative 29. So you're going to notice I subtracted 29 from both sides. It'll cancel out here. And what are you plugging into your calculator? Negative 74 minus 29. Again, you might be like, is that a negative or a minus? Well, we were subtracting 29 from both sides. So think negative 74 minus 29. If you're ever struggling to figure out whether it's subtraction or negative, read it aloud or read it to yourself and think about what makes sense. You wouldn't say negative 74, negative 29. You'd say negative 74 minus 29. So plug that into your calculator. You get z equals negative 103. All right, moving right along. Question number 5. H minus 62 equals negative 36. We're subtracting 62 from the variable h. So the inverse of that is, I'm going to leave a little space there. So we're subtracting 62. The inverse is to add 62, or you could subtract a negative 62 as well. But we're going to add 62 as the inverse of subtracting 62. So add 62 to both sides. Again, on the left-hand side, this is going to cancel out. That's why we use inverse operations, to isolate our variable h. So in your calculator, you're going to plug in negative 36 plus 62. That's going to get us h equals 26. All right, number 6 is already done for us. What's happening to the variable b is we're adding by negative 18. The inverse of that is to add positive 18, so you can see we do that on both sides. It's going to cancel out on the right to leave you with b, and then do 27 plus 18 to get 45 for your solution. Again, you can leave it like this or write it with the variable on the left. When we do inequalities, it's going to be important to switch it as a separate step, because you're going to also have to flip the inequality symbol around. An equal sign means the same no matter which direction we point it or we have it written. But with inequality symbols, it changes the meaning. So I just want to stress that as we move on towards inequalities, don't just move the variable to the left and the number to the right without switching the inequality. That's going to be really important moving forward. All right, we're almost halfway done with our examples. We're only going through number 14 here because I don't want to put too much on your plates at this point. I want to make sure we have a good understanding of solving one-step equations before we move on to our word problems and things that are more complicated. So number 7, we have negative 55 equals r plus 49. What's happening to the variable is we're adding by 49. The inverse is to subtract by 49. So I'm going to subtract 49 from both sides. It's going to cancel out on the right. On the left, that's what I'm plugging into my calculator. Negative 55 minus 49. Again, negative 55 minus 49. And I cannot stress enough to make sure you're practicing plugging this into your calculator, because a lot of times the students have the correct work, but their solution is wrong because they're not sure how to plug it into the calculators correctly. You should get r equals negative 104 or negative 104 equals r. Number 8, negative 78 plus a equals negative 38. What's happening to the variable is we're adding by negative 78. The inverse is to add a positive 78. So we'll do that to both sides. So on the left-hand side, this is going to cancel out. On the right-hand side, what you're plugging into your calculator is negative 38 plus 78. Again, negative 38 plus 78. And this is going to get us a equals 40. All right, next to number 9, f minus 27 equals 39. What's happening to the variable is we're subtracting 27. The inverse of that is to add 27. So let's show that to both sides. Again, this is going to cancel out on the left-hand side. So what you plug into your calculator is 39 plus 27. We should end up getting a solution of f equals 66. Number 10, I am going to start by adding the opposite and rewrite this as e plus 22. So what's happening to the variable is that we're adding 22. The inverse of that is to subtract 22 or add a negative 22. Both are correct. So we're going to show plus a negative 22 on each side. Again, subtracting a positive 22 is correct as well. I just want to show it more than one way. Hi. So on the left-hand side, we're going to have these 22s cancel out. On the right-hand side, we're going to do negative 51 plus negative 22 in our calculators. And we should get E equals negative 73. All right, next two questions. Number 11, we have negative 14.8 plus G equals negative 21.6. What's happening to the variable is we're adding negative 14.8. The inverse of that is to add a positive 14.8. So we'll show that on both sides. Again, it's going to cancel out on the left-hand side where the G is. In your calculators, you're going to do negative 21.6 plus 14.8. So again, in your calculators, negative 21.6 plus 14.8. And our solution will be G equals negative 6.8. Number 12, what's happening to the variable is we're subtracting 18.21. The inverse is to add 18.21. So you're going to see that I'm going to do plus 18.21 on both sides. On the left, the variable, or sorry, not the variable, but the 18.21s will cancel out. We're going to do negative 14.6 plus 18.21. In your calculator, negative 14.6 plus 18.21. You should get D equals 3.61. All right, last two before I give you a little bit of independent practice to finish this video. We've got negative 4 3/4 plus G equals negative 2 5/6. What's happening to the variable is we're adding negative 4 3/4. The inverse of that is to add a positive 4 3/4. So you're going to see that I'll do plus 4 3/4 to both sides. The 4 3/4 on the left-hand side will cancel out, leaving you with G. What you will plug into your calculator. Remember, if you're still not able to plug this into your calculator, please let me know. Ask me. Show me your calculator. We can make sure you know how to plug it in. You're going to plug in negative 2 5/6 plus 4 3/4. Negative 2 5/6 plus 4 3/4. So if you're using the ABC button, as it is in a lot of calculators, and we can spend some time showing you how to use that in class, you're going to be using the ABC key more than once. Some of you may have to hit the second or shift key to be able to get the 3 boxes to pop up on your screen and fill in those boxes with the numbers. This is something that we'll hopefully have practiced in class a little bit prior to you taking or watching this video and taking the guided notes or working through it in class, but something you want to definitely be familiar with. And we end up getting G equals 1 and 11/12. All right, last one here. Y plus 3 and 1/5 equals negative 5 and 4/9. What's happening to the variable is we're adding 3 and 1/5. So the inverse is to subtract 3 and 1/5. Let's show that on both sides. It's going to cancel out on the left-hand side. What you're going to plug into your calculator is negative 5 and 4/9 minus 3 and 1/5. Negative 5 and 4/9 minus 3 and 1/5 to get negative 8 and 29/45. All right, so what I have for you is 4 questions that I want you to try. Pause the video, try these 4 questions. I would suggest listing what's happening to the variable and the inverse side by side. We'll talk through that when we resume after you've worked through these problems. Okay, hopefully you've worked through these 4. So number 1, what's happening to the variable is subtract by 19. So one possible inverse is to add 19. Remember, there's 2 possible inverses, but we can add 19 to both sides. Negative 37 plus 19 is going to get us negative 18 for our solution. Number 2, what's happening to the variable is plus 26. The inverse is to subtract 26. So in your calculators, you'll do negative 45 minus 26 to get A equals negative 71. Number 3, what's happening to the variable is add negative 17.2. So the inverse is to add a positive 17.2. So you're going to do negative 6.7 plus 17.2 to get B equals 10.5. And finally, you're adding 4 and 3/4 is what's happening to the variable. So the inverse is to add a negative 4 and 3/4 or subtract 4 and 3/4. So in your calculators, you're going to do negative 2 and 1/3 minus 4 and 3/4 or plus a negative 4 and 3/4 to get R equals negative 7 and 1/12. So we're going to pick up where we left off in the 6.1 guided notes, and that would be with question number 15. So the first 4 questions here are pretty straightforward. It says to translate each of the following sentences into equations. So we've done this before with expressions, both algebraic and numerical, and now we're doing this with some questions that involve equations, so algebraic equations. So number 15 says the sum of a number and 12 is negative 18. We have to recognize that the word sum means addition. So we're taking a number or a variable n plus 12. The word is going to represent our equal sign. So we can write this as n plus 12, or any variable we choose, equals negative 18. In number 16, this one says the difference of a number and 7 is negative 11. We need to recognize that the word difference means subtraction. So we're going to take a variable n minus 7 and set that equal to negative 11. So n minus 7 equals negative 11. Again, just recognizing some of those words from earlier on in the year. Number 17, it says 16 is 10 less than a number. Less than is not the less than symbol here, although we will see that in the second half of our unit. Less than represents subtraction. So 16 is 16 equals. And then 10 less than a number means taking 10 away from a number. So we're going to have 16 equals n, our variable, minus 10. So we have 16 equals n minus 10 for our equation. All right, number 18, we have negative 25 is going to be negative 25 equals. And then 18 more than a number. The phrase more than represents addition. So our final equation is going to look like this. Negative 25 equals 18 plus n. So you might have heard my 2.5-year-old. He might have been looking for his Halloween candy. Don't tell him I took it. All right, let's go ahead and move on to some of the more challenging questions. So being able to set up an equation by a phrase is important for us to be able to do. But a lot of times in real life, these questions are more complicated. So let's take a look at number 19. It says, Jessica downloaded 54 songs onto her iPod, which I know this is a little outdated. We don't have iPods anymore. If you don't know what it is, just ask mom or dad. They might be able to tell you. This is 17 less than the number of songs that Kayla downloaded earlier. There are some examples in the textbooks as well, but I think you'll get enough here and in class in our practice to be able to handle these. So the one thing I want to mention here is in the beginning of the second sentence, they refer to this. What is this? What are they referring to? Well, if you read this carefully, you might recognize that they're talking about the 54 songs that Jessica downloaded onto her iPod. So the this refers to the 54 songs that Jessica downloaded onto her iPod. Now, if we look at parts A and B, it says to write an equation to represent this situation. This is a pretty standard type of question. In part B, we're going to solve that equation to find the number of songs that Kayla downloaded. So I want to highlight this because it tells us in part B what we're trying to find. We're trying to find the number of songs that Kayla downloaded. So one of the first things I always suggest students do, they'll come to me and they'll say, I don't know how to do this. I'll say, okay, what are we trying to find? We're trying to find the number of songs that Kayla downloaded. It's going to tell you that somewhere in the question. It's going to say, find this, usually at the end of the question. It might be in one of the parts as well. It might ask a question, which will tell you what you're trying to find. So I start by defining a variable to represent my unknown. I'm going to choose K for the number of songs that Kayla downloaded. Now you can choose any variable you want. I just try to choose a variable that makes sense for the question. Now, I know that the 54 songs that Jessica downloaded is 17 less than the number of songs that Kayla downloaded earlier. So less than indicates subtraction for us. So I know I'm going to have subtraction somewhere in my equation. So it's got to be 17 less than the number of songs Kayla downloaded, which is my variable K. So this is my unknown K right here. I'm kind of annotating this question like you would do for English. And again, the number of songs that Kayla downloaded represents our unknown. So 17 less than K is K minus 17. We need to set that equal to the 54 songs that Jessica downloaded. So 54 is equals 17 less than K, K minus 17. Now, sometimes I have students who try to set it up solving it in the problem, like they'll write K equals 54 plus 17. That's okay too. That would be equivalent. That would be correct. But I know one of our questions will be a multiple choice question where you have to match the equation to the problem, and it won't be set up like that. But there are equivalent equations you could write, like K equals 54 plus 17. That can also work. All right, let's go ahead and solve this equation. So I'm not going to write out what's happening to the variable, but I am going to think through this. So what's happening to the variable is we're subtracting by 17. So the inverse of that is to add by 17. So we do that once on each side. And in your calculators, you're going to plug in 54 plus 17. So we are going to get that K equals 71. What does this mean? Well, it means that Kayla downloaded 71 songs. Now, it doesn't say that you have to write a sentence. At the very least, label your answer. So 71 songs. But it tells us that Kayla downloaded 71 songs. And I always want to stop and think, like, does this make sense? Well, if Jessica downloaded 54 songs, and I know that that's 17 less than the number of songs Kayla downloaded, I know that Kayla had to have downloaded more than 54 songs. So if I did this problem and got something less than 54, I should realize that my answer doesn't make sense. So I should always stop and think at the end, does my answer make sense? Is it reasonable? And in this case, it is. All right, let's look at another one of these. So number 20. This one you might recognize came from the pre-test that you did. The Jefferson Memorial in Washington, D.C. is 129 feet tall. This, the 129 feet, in fact, I'm going to annotate this a bit by making some arrows here. This is 30 feet taller than the Lincoln Memorial. Recall that taller than indicates addition, right? So part A says write an equation to represent this situation. Part B, solve your equation from part A to find the height of the Lincoln Memorial. I like to start there. Again, don't come to me and say, I don't know how to do this. I don't get it. At least figure out what you're trying to find and define a variable to represent it. So the variable I chose here was h to represent the height of the Lincoln Memorial. I didn't want to use L because I knew it would look a lot like the number 1. So I just went with h. Now, I know that the height of the Jefferson Memorial, the 129 feet, is 129 equals 30 feet taller than, this will be 30 plus the height of the Lincoln Memorial, which again, this represents, I'm going to highlight it in blue, our variable, our unknown, h, so plus h. So my equation is 129 equals 30 plus h. Just take it basically word for word and translate it. It's not quite as easy as these questions here because there's a lot of other words around it, but it's very similar if you break it down and just pull out the information you don't really need or the extra words. Let's go ahead and solve this. So what's happening to h is add by 30. The inverse is to subtract by 30. So plug 129 minus 30 into your calculator, you'll get a height of 99. And this means that the Lincoln Memorial is 99 feet tall. Again, at a very minimum, you need to label your answer as 99 feet. You also want to think, does this make sense? Well, it says the Jefferson Memorial is 129 feet tall, and that's 30 feet taller than the Lincoln Memorial. So I know that the Jefferson Memorial should be taller than the Lincoln Memorial. All right, we will see a multiple choice problem on this here in a few moments. But until then, let's take a look at a couple of other problems. So number 21, during the night, the temperature dropped 14 degrees to -9 degrees Fahrenheit. What operation does the word dropped indicate for us? Again, this is just breaking down or annotating our information. Hopefully you're thinking subtraction. It does. All right, part A says to write an equation to represent this situation. B, solve your equation from part A to find the temperature at the beginning of the night. That's our unknown. So let's go ahead and define a variable to represent that. So I chose T, although it looks a lot like a plus sign, so be careful about that. But T is going to be the temperature at the beginning of the night. So we're going to start with T. The temperature dropped 14 degrees. So that's T minus, for subtraction, 14, and it ended up at -9 degrees. So T minus 14 equals -9. And again, I like to translate it word for word. A lot of students, again, are going to try to solve this instead of just writing an equation and then solving the equation. That can get pretty tricky, especially once we mix in negative numbers. So what's happening to the variable t is minus 14. The inverse of that is to add 14. So in your calculators, or mentally, do -9 plus 14. The temperature at the beginning of the night is 5. So our answer is 5 degrees Fahrenheit. That was the temperature at the beginning of the night before it dropped 14 degrees to -9. All right, similarly, number 22. The difference between the record high and low temperatures in Anchorage, Alaska is 124 degrees. The record low temperature was -38 degrees Fahrenheit. Now the word difference, we've already seen this today. What operation does this indicate for us? If you're thinking subtraction, you're correct. So part A says write an equation to represent this situation. Part B, solve your equation from part A to find the record high temperature. So again, we're trying to find the record high temperature of Anchorage, Alaska. All right, let's define a variable to represent our unknown. H equals the record high temperature. Now, we know the difference between the record high, which is H. So this right here is H. I'll actually highlight that. Our record low temperature, which they tell us in the problem, the record low temperature was -38 degrees Fahrenheit. So this is going to be -38, is 124 degrees. So my equation is going to be H, record high, minus my record low, -38, equals 124. Again, don't try to solve it. Just write the equation and solve that. Now remember back when we did this before, we did add the opposite in the equation to start. So we would write that as h plus 38 equals 124. The inverse of adding by 38 is to subtract 38. So do 124 minus 38 to get 86 degrees Fahrenheit. So that's our record high temperature. If you do this wrong and you add 38 to 124, you end up getting an answer that isn't really reasonable. You end up getting 162 degrees Fahrenheit, which that's way above a record high temperature here in this area, let alone in Alaska. So definitely think about that and make sure it's a reasonable solution. In this case, 86 degrees Fahrenheit is. All right, so 23 is that multiple choice question that I said we would see later, similar to the Lincoln Memorial question and Jefferson Memorial question, similar to the question we had about Kayla's songs that she downloaded. So let's read through number 23. There are two different routes for the Iditarod Trail Sled Dog Race. During the odd years, the race takes place on the 1,161-mile southern route. This is 49 miles longer than the northern route that takes place during the even years. Which equation can be used to find the length of the northern route? So our unknown here is the length of the northern route. So I chose n to represent that, both here and, of course, in all four of these answer choices. So we know here that the 1,161-mile southern route is, so again, the this, you're going to see that multiple times, refers to the 1,161-mile southern route, is represents our equal sign. I'm going to just highlight this in green. So 1,161 is equals, let me go ahead and type that, 49 miles longer than. The phrase longer than is going to indicate addition. Plus sign here. So we've got 49 plus. So let's set this up. The length of the northern route, that's my unknown. So that's going to be this right here. So that's going to be my variable n. So 49 plus n. Let's look through these choices. Do I see it? I have 1,161 equals n plus 49. It's not exactly the same here, but what I do know is that addition is commutative. So I could write 49 plus n or n plus 49. This first equation is equivalent. If I look at choice B, that's not the same. 49 plus n and n minus 49 are not the same. If I look at the third one, 1,161 plus 49 equals n, also not equivalent based on where my equal sign is here. And then finally, choice D, you should never choose choice D because if you solve that equation, you would get a negative value. And the length of the northern route cannot be a negative distance. So it doesn't even make sense. You should definitely be able to eliminate choice B right off the bat, or choice D right off the bat. Choices B and C may be a little harder to eliminate. But again, I always suggest for multiple choice, find your solution first and then see which one matches your solution from there. All right, we have one last question, which is a little bit of an extra challenge. It says if a number x satisfies x minus 12 equals negative 15, find the numerical value of 4x minus 8. So let's solve the equation. X minus 12 equals negative 15. The inverse of subtracting by 12 is to add 12. So you end up getting x equals negative 3. Now, replace x with negative 3 in this algebraic expression. So do 4 times negative 3 minus 8, which is negative 12 minus 8, or negative 20. You will not see a question like this on a quiz or a test. However, you will see questions like 23, 22, 21. 21 and 22 go together. But 23, 20, and 19 also go together. They're similar types of problems where we say that this is something compared to your unknown. So make sure you look through those. Again, I can't stress enough that if you feel a little uncertain about this, that's okay. The solving the equation part, you should not. You should feel pretty good about that here. The writing the equation is a little bit trickier. That's something we are going to spend some time focusing on later on this week in class, or focusing on in our live session. Could also be something that we focus on some later videos or activities during the week. Thanks for listening.